Okay, so what is this is the agenda for today. So we're going to talk about what is a weldment, and essentially for this, a weldment we are referring to as a welded frame, as opposed to a bunch of plates welded together. From the update yesterday, we're now able to put weld symbols on drawings, so that helps a lot. But we're going to focus on the geometry creation of welded frames, like we see in this image here. Now, if you've been using Onshape, you'll notice that there is no weldment feature in the user interface. And that's because we haven't actually officially released one yet. So what I did around about 12 months ago was to use our custom feature script language to build a feature called beams, which is able to build these weldments. So what we'll do is just talk briefly about what feature script is, how you use a custom feature. I've got learning feature script on there. I'll just point you to some resources that you might want to read and follow along, some tutorials, some videos if you're that way inclined to build your own features. And then we'll take a look at the feature in more detail. And then also at the end, we'll take a look at how do you add your own profiles. Now today as well, I am releasing a newer version of the beam feature. There is some improvements to it, a lot of requests. So get a lot of support tickets in. Although this is not an officially supported feature, and therefore support don't really support it, we are mindful that this is one of the most popular features available, and a lot of people are using it. So if we can get it fixed and working for more people, then of course we're going to try and do that if we can. Okay, so this beam feature is written in feature like I say, it was actually started as a side project just to try and build it. There are a number of CAD systems that have a similar capability, so the initial idea was to try and replicate some of that, and then as more people requested more capabilities, I put them in there and eventually released this as a feature around about fall of last year. Okay, now just a brief word about feature script itself. Don't be afraid every time I mention that. It is basically just the background programming language that the Onshape developers use to build the features inside Onshape. So in the example there, the extrude feature is written in feature script. The user interface, the dialogue of the extrude feature is all feature script. So basically, I use the exact same technology to build the beam feature to get some to create weldments from that. And like I say, you can do the same if there is a particular feature that we haven't yet developed in Onshape. Of course, the first thing you can do is request it. If you go to the forum and go to the improvement requests area, you can create an improvement request, or if somebody else has already done it, you can vote on it. The more votes a feature gets, the more likely it is, or the faster it is to get into the product itself. If there is no, or if you're that way inclined and you want to actually build your own features, like I said, you can use a feature script. You can modify our source code to suit your needs, or you can create a brand new feature like I did with the beam feature. Okay, when you take a look at the beam feature, there is an instruction page on there which basically gives you an outline of what the user interface looks like, what each of the individual boxes does, and also some options down here. But first of all, let's take a look at how you'd actually get to use a custom feature. Now, you don't actually need to know feature script in order to be able to use a custom feature. If you go to onshape.com/feature script, okay, this is a page where we have put a number of examples on. Now, I mentioned that we have got a lot of support tickets, requests for different types of geometry, different profiles, and so on for the weldment feature. There's also some issues with different kind of trimming scenarios weren't working, which is one of the reasons why I updated the feature. But these are all examples, and there's the beam feature itself. Now, these are all examples that are what they say. They are examples. So they are not really officially supported by Onshape. They are just examples we put up there to show you how to use FeatureScript or how it could be used. But for example, the spur gear feature and the beams feature have been, tens of thousands of people have used them. So obviously they are very popular. Down the bottom of this page, there are resources to help you learn FeatureScript. Again, if you're that way inclined. If not, you can just use these features under this More button here. There is a bunch of features that have been created by the community that you can use straight off. So if you wanted to actually use the beams feature, you hover over it and select use it. Now this is actually pointing to the oh no, it's not. He's done it already. What a good man. So I actually put a request into the guy who takes care of our website to update this link, and he has indeed done that. So thanks for him for doing that. So when you click on use it, what that's actually doing is going to take you into the feature. And in fact, what I need to do is actually make that public as well. Public. Okay, so when you go into the feature, you'll find this open screen that we showed in the PowerPoint just a moment ago, and at the top there will be a button to use it. Okay, because I own this feature, it's not showing it on here, but you will see a button to say use this feature. If you click that, it will add it to your user interface. Okay, another way of accessing it, if I go back to my empty documents here, is along the user interface on the top, on the right hand side, there is a small button with a plus sign on it that says add custom features. So when you click on that, it's going to list, first of all, it will show you all your own documents and documents that have been shared with you, teams and labels. So if you've got some of your own FeatureScript features, you can add them from here. If this FeatureScript samples link here will take you to that web page that you were just seen. Okay. And also the community spotlight. These are the ones that the users have created. So you can click on one of these, and it will list a feature which you can click and add to your user interface and use that. Okay, but I'm going to use in my documents FeatureScript Beams version 2.0. And in there are two scripts. We won't bother with this one. You only need to use this one if you intend to create your own profiles. If you don't, that's fine. You don't need to use that. But to add the beam feature, just select beam there. Okay, you get a message at the top, and then you get a little icon here that says BE, short for beam. Okay, so how do you use that? If I let me first of all just create a real quick sketch on this top plane, and let's make that say 1000 by 750. Okay, what the beam requires is either a sketch or, in this latest version, some solid faces as well to actually, or solid edges I should say, to actually generate the beam profile. So once you select the beam feature here, you will see the user interface that was generated from FeatureScript for this, and then you can specify a number of lines and arcs that you want to select. So let's just select one just to take a look at some of the profiles for a moment. So my intention before doing this webinar was to add lots and lots of profiles. I'd spent a couple of hours doing that today, but issues with DXF, and I'll talk about that later, kind of scuppered that plan. So what we have in here is the original set of profiles that came with the version 1 of this feature, but I've also very graciously in the ISO, our friends from Ndraft have generated all these profiles, and they've kindly let me use those to put in the feature. So if you want an ISO steel beam of a particular size, you can see that generates that profile for you. So we are a little bit lacking on the ANSI inch at the moment, but what I will do is, based on requests that I receive in the forum, particularly if people have examples of profiles, I will systematically add them to this feature, so to build out the library to make it a little bit usable for more people. So like I say, you can go for different profiles. In this case, we're specifying a diameter of a tube and the thickness, or you could have. I was playing around with I was trying to add the entire 8020 profile library in here today, but I will add that over time. I managed to get the first two inch series, the 1 inch and the 1.5 inch, because what you'll see is some of these profiles are really quite crazy. And the DXF files that came from the 8020 website weren't exactly ideal, so I had to fix quite a few of these up in order to get these profiles to work. So I will, like I say, go through this and add those in there. So you can do steel profiles, bought in aluminium sections like 8020. I've added in here some basic timber sizes. Okay, and we'll use the timber sizes later just as a simple example of how to build your own profiles. Okay, so that's just a simple example in there. Okay, so let's just go for a S-beam. Let's make a big one there. Okay, so when you select an edge, you are going to get 3 manipulators on there. The first manipulator there gives you rotation, and what you'll see on the interface there is basically giving you the same profile or the same information there. So for a lot of the time, it might be easy just to type in, say, 90 degrees in there just to get the same effect. Okay, whichever you prefer. The other thing to bear in mind is these two arrows, and if I look on the end of the profile, it makes it easier to see what's going on. So each of these profiles has 9 origin points, so 3 along each edge and one in the middle. So this allows me to drag this profile relative to the original sketch line that you created. So you can go up, down, left, right. So this is very useful if this sketch profile is, perhaps the top of a table, and you want to keep the beams inside that particular section, then that will actually do that for you. Now, as you add more sketch entities in there, okay, what you might find is that sometimes this might jump around, and the reason being is that again, I might have to come up with a slightly better algorithm to work that out, but it's basically basing it off the number of or the type of face that you are selecting. So it's probably a good practice to build your frame or select what you're going to use first before you start modifying the position of the actual individual beams. Okay, now once you have those, you'll see those in this case are overlapping. There is a miter all joints option, okay, which is going to give you a perfect miter in there. And you'll see as you drag this out, the miter is going to be maintained. As you rotate it around, the miter is going to be maintained. So if you're going to have some kind of crazy angle on there, you can still miter those edges if you wish. Okay. Another option in this dialog here, you can keep the miter all joints switched on, but there's another option here for creating butt joints. Excuse me. Now the butt joints is looking for a sketch profile. So, sorry, a sketch vertex, I should say, because I didn't want to use the edges of the face because some of the profiles, especially things like 8020, are very complex. So picking a vertex will actually give you a butt joint on that corner, and a little arrow will appear. The arrow may not necessarily be pointing in a logical direction, but all you need to know is that if you click the arrow, it's going to flip the direction of the butt joint. So if you wanted to create, let's just add all 4 corners. So if you want to create it so that the outside lengths were long and the inside lengths were short, then you can do that as well. Okay, so nicely graphical, very very much manipulating on screen to get the geometry that you require. Okay, and if we look again, let's look down the right hand side of this model. What you'll see is that we've automatically, let's look down the bottom here, we've automatically trimmed this other profile in a logical way, or how it would be done in practice. So rather than trying to create something that would fit snugly up against this other profile, it's common practice just to cut those back. You can, if you wish, if you press coat joints, okay, you can actually close that gap if you want, but the default is having it switched off. The last two options there, trim beams and merge beams, are refer to something different. So we'll look at those in a little while. Okay, so that's the basic premise of using the feature. So you add it to your user interface. You can pick some edges or faces off a model. Edges off a model, and then position your beams, modify the corners, and trim them back if required. So what I'll do now is take a look at. In fact, what I'll do, just for this purpose of this, I'll just make a copy of this. Just so I can edit this workspace. Okay, so in this document, what you'll see is when you, and in fact, just bear with me 1 second. I just want to show something of interest here. So the original version of the beams feature, which is, can't find it. Hang on. Beam. This one here. So I've renamed that to call it Legacy. You'll see down at the bottom right here that it's been linked 1,500 times, which basically means that it's been used 1,500 times in other people's documents. But 622 people have made copies of it, so it could be used any number of times from their own local copies. And typically, you would copy this script again if you wanted to add your own profile. All right, let's go back. Let's go back to this feature. So if you did make a copy to add your own profile, you'll find a number of examples. So there's this like classic Weldment shape in here. There is something a little bit more sporty with a go-kart, a table, which is just following a lot of the processes I was just showing a moment ago. Cross frame, and also in here there's like some kind of shed type geometry. It's not finished, but the idea here was this was using faces or edges off a model rather than an actual sketch itself. Okay, so what I'm going to do is in this copy here, let me just build some of these. Perhaps might not do all of it, just to show you some of the examples of what you might want to do. So in this example of this go-kart, there is a number of sketches which have been generated to define the space envelope of the product itself. Now, once you've done that, you can then go ahead and use your beam feature, and let's go for an ISO square hollow section. Let's choose one of these sizes, and then when I go ahead and select these edges, it doesn't have to be in any particular order. You'll see it will populate those for me automatically. And again, if you wanted to do the miters, you can miter all those joints, and it will do that for you. Now, if you can imagine how long this would take, just that single one feature, how long that would take, just using sweeps or extrudes, it would be very time consuming. Well, you'll see it down the bottom here, it's actually created 10 parts. So it is actually treating those as separate parts. Currently, this feature does not, the code is there to generate cut lists, but currently it does not able to generate the cut list. So we're focusing mainly here on the actual geometry creation itself, and then you can create drawings of it as well to add any kind of weld details or dimensions on there as standard. Okay, so that's say my first feature, and in fact, you know, I've done that from one sketch there, but actually I could have added, if I'm using the same profile, there's no reason why you know, I couldn't use some of these other edges on here. The only prerequisite here is that a corner can only have two edges. So for example, here, if I pick this as well, then I won't be able to trim it back because this corner's actually got four edges going into it. So if in the instance where there is more than two edges in, then at that point you will then have to go ahead and create another feature. So in one feature there, I've created 16 parts. Go ahead and create another feature. It will remember your last settings. So if you need to create more than one feature, it's not such an imposition because it does remember the previous selections. So I can go ahead and enter those, select those in there. But what you'll find now is, having done that, I can now start to do some trimming. Okay, let me just hide some of these sketches so we don't really need them anymore. Okay, so there's two types of trimming that you can do. Now, this is where the trim beams feature comes in because I'm creating a new beam and I want to have it interact with an existing beam. So let's create trim beams. Now, there's two options here. You can either do a planar face or you can trim to a part. Now, for performance reasons, planar face is a lot faster, as you can probably imagine. What you'll find, though, is that if you want to have a coped joint, so the profile actually following the other beam, then you would have to use parts rather than planar faces. Also, the other caveat there is if you are using parts, then this profile needs to be the same size as this one or smaller, because if it overlaps anywhere, then it doesn't know where to trim it up to, and then it's going to fail. In those instances, if this profile is bigger than the existing profile, if you use planar face, it will trim it back to the correct position. Okay, so you can see that beam has been trimmed back there. Let's add some more faces. Let's pick this face behind here. Okay, now we could actually use faces on this one as well, but for the sake of saving a little bit of time, if you select parts to trim and select this one here, you'll see it's going to trim both those beams in 4 places. So otherwise you'd have had to pick, well, at least 2 faces or 1 part would give you the same the same result. Okay, so you can see we're actually building this up reasonably fast. Let's go ahead and, in fact, on that second beam here, and again, just in the interest of saving number of features, you can add these cross beams in. Likewise, you can pick these faces to trim to. One other thing that you need to remember as well, and I'll go over these as I summarize later, is that in order for a beam to be trimmed, it does actually have to physically touch it. So if this was off in space somewhere and you selected this face, it would not trim. But you see, selecting that one face has trimmed this beam, and it's also trimmed this beam over here as well. So it will work out the number of selections is not too onerous to actually get the features that you want. Okay. Now, if there is any kind of performance delay, it would only actually be due to the fact that I've got too many beams in one feature. Okay, it's taking a couple of seconds. It's no big deal. Because what's actually happening every time you create a feature in Onshape, it can be any feature, not just a feature script or a beams, is every time you select something, it's got to recalculate the feature from scratch. So the more data you've got in one feature, the more work Onshape has to do to actually generate that, generate the profiles or generate the geometry. Okay, but you can see, this is looking fairly good. Got 2 beam features in there. Last thing we'll do is just add in some. Just hide some of these sketches. Last thing we'll do is just add some tube on here. So again, we'll go back to our beam feature, change it to the mild steel hollow tube. Not really bothered which one. And let's just add some. Pick some of these. Okay, zoom in to select the short edges, and perhaps pick these ones as well. And again, remember, you don't have to do them in any particular order. So if you need to do the zoom in items at the end, that is fine as well. Now, one of the options here, from a manufacturing standpoint, of course, you would actually bend this out of tube. So rather than have individual parts. So at the moment we've got 42 parts there because the feature is assuming that you want these as individual parts. If you select merge beams, you'll see that goes down to 26 in the bottom left corner here. So each of these now is created out of two pieces of bent tube, okay, which is obviously more realistic with regards to manufacturing these parts. Okay, let's just do trim beams again. So trim to that top face. Okay, and that face there. And we'll trim to this face over here. All right, almost there. Okay, I know it's not very exciting watch somebody build something, but just to show you all the different types of variations of capabilities that we have here. Okay. While I'm doing this, somebody's there asking why do some of the profiles have material specifications in the names? That is not related to the actual profiles themselves. That is just relating to the standard that it's generated from. So for these mild steel hollow iso tubes in that material, then these are the thicknesses that you get. By default, at the moment, it's not possible for feature script to assign materials or colors to parts, which is why you'll see, or names even, which is why you see different colors, different names, and no material. But what you could do at the end is box select all these items and add material to that. Okay, now I've added these in here. I've missed out this middle one here on purpose. The reason being is because this actually will intersect because when I do merge beams, I want this one to be one piece of pipe at the back here, but I don't want this to be part of the same pipe. Now then, if we do some trimming here, you'll see some rather nice pieces of geometry are created. So in reality, if you were going to assign this or add this tube to this square tube, then when we trim it, if we could do a planar face, which is going to do that. But in reality, we don't want that. If we do parts to trim, what you see, it's going to give us a nice square cut. So rather than having to, you could do it coped if you want, but trying to generate that profile manually or even by CNC methods would be difficult. So get a nice square cut to be able to weld those parts together. Another question here, can you pick parts after creating them, merge them together? Yes, absolutely, you can do that. Once they are actually generated, they are individual parts, and I'll actually show an example of that in a moment. So let me just trim to this part, which is going to give me the nice crescent shape on the beam. Okay, and let's just do a planar face down here. Trim that face up real nice, and then this pipe at the front. Trim to that face. Where is it? Trim to that face. Okay, and we're looking good. Okay, last piece, last beam. Again, it's going to remember the previous selections. Select that. Trim to the parts. Trim to that one and trim to that one. Okay, and then we're going to get a nice trimmed pipe work. There is a little bit of an intersection there, so I could actually trim this one to that, but we'll assume for the purposes of manufacturing this go-kart, we're not too bothered about that. Now, I say we have here now 30 parts make up this this design. They haven't, like I say, they have no names, but you can take any of these and assign materials for them, or you could assign colors or whatever you need to do with those. But now, because they are just parts, if you wanted to do a mirror, for example, we'll go to part mirror. The mirror plane will be the right plane, and you'll see this is one part because it's merged together. That's one part, and this is one part again because we use the merge. So in this instance here, where we're able to generate a lot of the profiles very quickly and they're actually trimmed up accurately within the one feature, or 5 features and 34 parts. Another question there, is there a direct interface to an FEA product? From a beam FEA problem, the answer to that is no. But some of our partners, particularly people like SimSolid, who are able to do meshless FEA, it doesn't actually matter that the beams actually have solid, are actually defined correctly. They're able to do this meshless FEA and actually generate that. So the question, if you want to create a beam study in FEA, then the answer is no, as far as I'm aware. Okay. Nice thing about this now is if you wanted to create a drawing, let's just go ahead and create a drawing of this assembly. Now, well, I say assembly, of course, it is a part studio. So if I come in here, then actually what I want to do is to take the entire part studio, or I could have put it into an assembly and group them all together. And let's just go for a right-hand view. Okay, so there's the actual profiles. I'd say the nice thing now is that as of yesterday, we now have weld symbols. So if you wanted to put all the weld symbols on there, so let's just do a fillet weld of 3mm all round, on there or something like that. Then you can document your welded structures as well. Okay, the question is how will this work if I want to make a 3D laser tube parts? The answer to that is I'm not sure. But what you'll find is that if you take, say, one of these parts here and I hide all other parts, oops, I don't want to do that. This part, hide other parts. Yep. Okay, you'll see that we are getting the exact geometry created for this tube. So if you've got some way of generating the CNC or the laser cut paths for these tubes, then you can do that very easily. Okay, just do a real just a recap from what we've seen so far, and then we'll take a look at some other areas. So first of all, this is a feature script example. Like I said, it is not officially supported, but we will support it. Beam corners can only have 2 edges. If you have more than 2 edges, you have to create another feature, which is the same thing where it says beams with multiple loops may need a new feature. And what that means is that because of the way it determines where the plane that defines the direction, it might not behave exactly as you expect. So in those instances, you might need to create more than one feature. Trim beams must touch. Like I mentioned there, for a trim to work, it actually has to physically touch the other beam. There is an issue with regards to short sections that may get trimmed, because what you managed to actually get this feature to work, I had to kind of make an educated guess of when we're doing trimming of which of the short pieces get removed. So by default, it works on a percentage of the overall volume of all the parts or something like that. So if you're doing trimming and some of the parts are disappearing and they shouldn't be, the likely is that it's the short section that might be getting trimmed. So you've got an option: you can either extend it, or there is a constant actually in the feature. You could actually edit the feature and change the constant to make it a little bit more forgiving. Okay, coped beams must be fully enclosed. Like I mentioned there, similar to the trim beams, the beam that's being coped mustn't be bigger than the other beam, otherwise it doesn't know how to trim it. Beam paths currently only work with lines and arcs only. So if you're looking to do things like splines, technically it's possible, but for the scope of the project, we kept it to lines and arcs. Likewise, beam profiles are lines and arcs only. So even like the 80-20 profiles, they are all made up of just lines and arcs. So that's a requirement there. And as I painfully am aware as of today, is beware of imported DXF files. Make sure that the DXF files are fully enclosed. When you actually generate profiles, it's easy enough to test, so you can see the original sketch and reference it to the 3D model, and then be able to see if there's any issues with the profile. Okay, someone's asking, can it work with ellipses? It's currently set to no. I don't think there's any particular technical reason why it couldn't, but there is a filter in there at the moment to stop that. And then there's another question about symmetrical beams. The beams don't need to be symmetrical. So, for example, if I go back to this, and let's just edit one of these features. If we go to the 8020 profiles, for example, I think one of these, well, symmetrical still. Let's go for the 1.5 inch series. I can never remember what the numbers are. Something like, no, that's a big profile. Anyway, the short answer is yes. Well, I can't remember what these profile names are. There you go. So there's a non-symmetrical profile. So in these cases, if you're using a non-symmetrical profile, the way it works out the positions of the location positions, it takes like a bounding box of the profile, and then it will move. It'll move those to that bounding box. So you'll see you've actually got. So you can actually have this going off into space like that, for example. Okay, question, is it possible to create my own standard profiles? Yes, it is, and we'll take a look at that in a moment. Ideally, I would have every single profile in there, but it's just been literally a matter of time to get those done. If I had the time, I would certainly do it. So I know a lot of people have created their own profiles, and let's go through the process of how to do that. It is not really for the faint-hearted. You don't really need to know feature scripts, but it helps if you've got some kind of programming background and a lot of patience. Then it's not so bad. Okay, before I go into that, what we're looking at here is the newer version of this of the script. Like I mentioned, more trim scenarios now work. This was in direct response to a number of users who had used the profiles and saying, for some reason, this trim isn't working. And it was due to the underlying algorithms that I'd used, so I had to change a lot of those. But what that allowed me to do is to also use edges from a solid, and I'll explain why in a moment. Better performance than the original version, thanks to the feature script profiler, and the better profile generator. The question, when was that released? About an hour ago. So I've literally only just, it's not quite as finished with regards to profiles as I wanted it to, but I put it out there to let people use it. Now, with regard to that, please, the original feature is still available. You will see the caveat at the bottom there that this version is not compatible with the older version. If the older version is working fine for you, please carry on using that. If you want to try the new version, then please use that. So it's up to you. But what you'll find is that this new version, because it is not, I shouldn't really use the word version, but it's not an up-versioned copy of the original. It's actually a brand new feature. Okay, so there's no backwards compatibility with the ones that you've used already. So like I say, use the original one if you prefer, use the new one if you want as well. The profiles are compatible in both. So if perhaps you like some profiles in the new version and you want to backport them into your old version, you can do that. Those will still work. Okay. Question. Can I demo how to control this visibility of the profile placement points? Well, those are fixed, so they are relative to the box of the face. So again, let's just go back to this real quick. So if we look at this profile, so literally the points are in the center and 3 along each edge in the midpoint. So as you move those will move along. Okay. Now, again, I used the same method that other CAD systems use. You could actually position this in a little bit more. You would have to edit the script, but you could actually have it specifying the actual number of millimeters or inches along a direction. But in general, we'll use the sketch to define any kind of nuance with regards to an offset for a beam. Someone's asking about upgrade path from the old version to the new version. So the question there is really, like, they are separate features. Like I say, if you're blissfully happy with the original feature, carry on using that. But I'll just show some benefits of using the new version over the old version, and then we'll look at adding own profiles as well. Now, if I was to create a brand new Part Studio, and if I was using the old version and I wanted to create a simple frame, and this is the where is it? This is the frame that I use an example. I won't go to all the detail, but just the main parts of the frame. Then you'll see, using the old version, what kind of hoops you have to jump through. So first of all, you have to create a excuse me, a network of sketches. So you could perhaps sketch on here, and then, like I say, it's only a rough. We'll do something like this. Okay, so I'd have to do this one. Now I could mirror it over the other side, but likely I'd want to actually build this up in one profile. So I'd do something like this, and then I'd sketch on here, and I can use that edge. I've got a copy of that over there, but then I've got to connect the back, and I've got to create a new sketch. Okay, so you get the idea. If I want to build this as a network of sketches, then I have to do it as a number of sketches to actually achieve what I'm trying to do. Okay, and then I'd have to create a sketch to close these corners off, and so on. So that means then when I created my sketch, let's just go for any old shape. In fact, let's go for rectangular tube. Then it's a little bit big. Okay, I can do this, and I can add my profiles in here. But actually, a quicker way to do that in many cases, and again, if it was going to be a little bit more complex, would be actually to create a solid. So let me just get rid of these three, and I'll just set that back to the front plane, so I don't need this plane either. So if this is the side profile of what I'm trying to create, then of course what I could do is just extrude it symmetric, the size that I want it. And what I'll do here is just change the transparency just so you can see it a little bit better. So now in this new version, you now get the option here to, again, let's go for, let's just use pipe. So when I select on here, you can now actually pick individual edges. So if you've got a space envelope that you've generated for a particular feature, you can now use solid edges to generate the profiles, which you couldn't do before. And that's probably one of the main benefits of this new feature. If you don't need that, fine, stick with the old one. But just bear in mind that even though I have released this new version, your older versions will not get the little blue update icon on because they have not been updated. Okay, it just means that any new users who go to the website will be getting this new version. All right, let's take a look at building some of our own profiles real quick. What you'll see here in this instructions here, I put a little link here to, well, it's actually going to the forum post, but inside the forum post, there is a video that explains this process, so you can actually follow along with that. But let's just do a real quick example for you now. Okay, and let's go to, let's use this profile just for argument's sake. Now, when we what you'll see, if you make a copy of the original document, then you can add your own profiles. Then you can. There's the actual beam feature itself, which is quite involved. It's around about 1,000 lines of code, 933. You don't need to touch that. Don't worry about that. Then what you'll find is a tab called Beam Profiles. Now this is where all the good information is. If you wish, you can break it out into multiple tabs. So for example, here you see I've got a line here that says import, and it's pointing to 8020 profiles, which is actually in a separate tab. Because there's a lot of data in there, I'll put them in a separate tab just to make it a little bit easier to manage. The way you do an import, there is this button here. So you import, you select the tab that you want to add, and it will do that for you. Okay, so it's pretty straightforward. So with regards to actually learning feature script, you don't really need to. Okay, what I'll do. Let's take a look at creating this timber profile here. So let me just go ahead and delete that. So if that wasn't there, this tab would look something. This tab would look something like this. Okay, so how you actually go ahead and add extra items in here. It's reasonably straightforward. So in a part studio, so create a blank part studio. It doesn't need to be in this document. It can be a different one. Create a sketch. Make sure that the sketch is on the top plane. It will only work on the top plane. If you pick the front plane, which I have done on several occasions, it won't work. The main reason being is because it's looking for the X, Y coordinates and ignoring the Z direction. So we'll create a sketch on there. From that point, you can either import a DXF or sketch a profile. Now, what you should be aware of is that the origin is the center or is the insertion point of the profile. So if I'm going to do a simple profile like a whatever size this bit of timber is, and give it some dimensions, and again I'm not going to bother about the actual sizes of this for now. If it's an imported DXF file, of course you don't need to do that, but once you do import a DXF, what you'll find is it does something like this. If I just copy and paste this over here, when you import a DXF, you'll get the option to move it using this transform feature. So what you might want to do then is you grab the little ball here, drag it onto the center where you want it to go, and then you'll see it'll snap to the center or to some other location. So when you insert DXF, make sure that you move it so the origin is where you want it to be. Okay, so that's that basic first sketch. So that could be my profile. What we need to do then is to either add to the toolbar, or if you've made a copy of it, of the feature script beams feature, you'll find it here called Beam Profile Generator. And I think on the video it's called Beam Profile. I changed it back again. So what this will do is asking me for a number of things. So first of all, what's the name? So say this is 2x4. This button here, unique profile. Again, some of these things are new, so they're not on the video. But the unique profile is basically saying that in this particular classification of profiles, every single one is different. Now, the classic example of that is 8020, because whereas in timber, you got 2x4, 4x4, 4x6, whatever, they're all the same shape, just different sizes. So the profile is not unique. But on something like 8020, the profile is unique. So by default, you can leave that switched off. Next is the units that you want it to be in. Now, this is totally different to the units of the document. Okay, so if you want to specify in inches, so even though this workspace is millimeters, you can specify in inches and the output will be in inches. And then what it's asking me for is a face. So we'll select this face here. And then a notice appears at the top asking you to open the feature script notices panel, which is this button right here. So if you click that, okay, you'll find some rather cryptic information in here. It's telling me units inch, this sequence. You don't really need to know what this data is, but basically that's saying it's made up of 4 lines. If I put some fillets on there, it'll have A for arc or C for circle, and then the points that generate this. Now, the reason why doing it as point generation rather than a bunch of DXF profiles, for example, is for performance reasons. Because if you imagine if you've suddenly got 2,000 profiles, every time you created a beam feature, it would have to load that part studio with 2,000 profiles in it, and that's just going to become totally unwieldy. So what I decided to do was to break down each profile into a number of vertices and entity types to be able to generate them much more efficiently. Okay, so we'll come back to this in a moment, but if you go back to the Profiles tab, these are this list at the top here, which is called Beam Profile Table. These are the individual standards. So you can see we've got ANSI inch, ISO, the mild steel, hollow, bent profiles, 8020. They will appear in that order as well. So if I wanted to put timber somewhere up here, I could put in there timber, and then a table name. It can be anything you want. So they call it timber table or something like that, and a comma to separate it. Okay, now you see straight away you're going to get an error because it can't find it. That's fair enough. So what I generally do is take the first few lines of another one and just copy and paste them just to get you started. So I'm just going to copy that and paste it here, and I'm going to call that, I'll just copy and paste that, timber table. Now, the thing that was most likely to get you confused is the number of curly braces. This format is very similar to, say, XML, which can get very complex if you're trying to read it manually. So generally what I try to do is to close some of these braces so you know where you're up to. And when you close something, you'll see feature scripts will highlight the opening brace as well, so you know where you're up to. Let's add another one in. So that closes that. Final thing it needs is a semicolon. Okay, and you'll see that error now goes away because it's got all the information it needs, albeit it's got no data at the moment. So in this here, we'll go the display name is going to be the subcategory. So we'll call this lumber. Okay, and the units are in inch. And then it's the entries that we're interested in putting in. So if we go back to, well, we don't have to go back to the tab. You can see it here still. What we're interested in is the sequence. So we'll need that. So let's just copy and paste that up here before the entries. Okay, and then in the entries, we'll have this profile here. Place that in there. Notice it's automatically got a comma on the end. If there's only one, it doesn't need that. Okay. Nice little button to press is this format button, because that will format it. It's also a nice check to check that you've not missed anything as well, because if there's an error in your code and you press this button, it won't format it because there's a problem. You'll also see perhaps some error symbols up in the top right here, and if you scroll down, you'll see, if I for example, if I take this semicolon out here, there is error there. There's an error at the top. If I press the let's just move that down just so you can see. If I press the format button, it doesn't work. As soon as I fix that, okay, the errors go away and the format button works as well. All right, so that in its basic form there, is the profile. So if I press commit is like save if you want. In fact, it's Control S anyway to save it. That means that all your changes will be committed. And then if you go back to this feature here, now just be careful if you are developing new profiles. What you'll find is that you've got the beam feature here, which is actually linked to the actual feature, which is on the website. But under this little button here, these are the ones which are local to your document. So make sure you're using this one and not this one if you're developing new profiles. In fact, generally what I do is I right click and remove that one from the interface just so I don't make the mistake, because you might press that and you'll find that your profiles aren't appearing and it can be very stressful. So I go ahead and create a beam. On the list now you'll see I've got timber. 2x4 is the size. So when I click this, regenerating, which means I've made a mistake again. Hang on. Beam profiles. What's wrong with that? So I'm going to go back to my Roll it back a little bit. Yes, sorry. Yeah, just that's my fault. Yeah, so let me just take this out here and then just explain that a little bit better. Like I say, it isn't very straightforward. It's difficult to get a grasp of it, but essentially, what you'll see here is that we've got the profile in here is the name of it. I put the name in the wrong place basically. So, and in there we have this thing called lumber, then the size. So that's going to give me an extra drop down menu. So this is the part I missed out. So like I say, it's good practice to just copy and paste it from somewhere else. Like I say, I can take this information from here, paste it here. I've got one too many brackets, I think. No, not enough brackets. In fact, not enough braces because I've added extra in. Okay, that's disappeared. Format Studio, commit. Yeah, so I missed out this part. So it's easily done. So, but once you've got the main structure in there, you won't need to change that ever again. This is like a one-off thing. So now if I go to my cross frame, go to timber, lumber, 2x4. Okay, so now we've got 3 entries rather than 2. So that's right. Select that, and now you've got this same profile with automatically the 3 location pieces on there. Okay, the nice thing about the profile generator is that if you go back to my parts, not that one. Where is it? Part Studio 2. Is that it's associative to the original sketch, apart from the name, of course. But if you go into here and we change this to be 200 by 120, okay, and then we'll change this to we'll edit that just to change the name. That's whatever it is, 3x4. Okay, this is basically going to just generate a new entry for me. So I can take this, copy it, go back to my beam profiles, and then after this entry, just put a comma, paste that in. I don't need that comma at the end there. And again, if I tidy that up, you can see you've now got a 3x4. Now, another useful tip as well is while you're working in here, it can get a little bit overwhelming. So you'll see on some of these, there's a little drop down, a little arrow to collapse. So if you collapse that, you can collapse individual ones, you can collapse entire ones. So particularly useful if you are working on a large set of beam profiles and you're missing some braces. If you collapse the profiles, you can see if they are showing the correct data. Okay, and then if you edit that now feature, you can now see you've got a bigger one, so you can do that. So it's all dynamic as well. So once you've added a profile, committed it, you can check that as well. Another way to use the beam profile option is to, if you look at this 80/20 profiles, which I was using this morning to try and get those profiles in there, is that you can, once you've got all the profiles available, is just put one of these beam profile generator scripts after each sketch. So it just makes it easy to say, okay, for that particular sketch, this is the feature that generates it. Okay, so if you're generating lots of profiles, you can do that. Okay, so it's questions. Ask a couple of questions. With the 2x4s, I want 3 with the 4-inch side vertical and 1 with the 4-inch side horizontal. Okay, so yeah, good question. So what you would do in that case, if you've got, if you've got something like this, 3 of those, and you want those to be at 0 degrees, well, let's do them at 90 actually, and then let's just miter those. For those instances there, you would then have to then go ahead and create a second feature to do that. And then you would take that feature, slide it over there, and then you've got that at the correct shape. And then you could do any beam trimming if you need to. Okay, question about the placement points. The placement points are defined by the bounding box. So for example, On something like this, it's very straightforward because it's square. But if you've got rounded edges, if you imagine squaring that off, it would actually put the points there. It's basically the same way as how it worked in SolidWorks. If you had a big fillet on the edges, in fact, let's just change that to something. Let's go to a rectangular tube. Okay, so even though you've got fillets on the corners, the actual insertion point is, let's just move it over. You can see it at the intersection. So it's the bounding box of the face. Okay, other questions. Rather than cutting and pasting, would it not possible to beam profile to add the code automatically? The answer to that is no, mainly because of security with regards to feature script. Feature script was written so that it couldn't be, so that it can only affect the feature it's working on. So it can't affect any of the features around it. It can't accept inputs from other places. So for security reasons and viruses and that kind of thing, it's kind of sandboxed within its own area. So for that reason, it's not possible to do it. But what you can do in this example here is, because I've added all these features one after the other, if I expand this, you'll see it's got all the data in one place. So I just did it all in one go and then just copied and pasted the whole lot in one go. Okay, and I think that's about it. So let me just go back to here. Make sure I didn't miss anything. No, I think that's it. I would say it is a new version. There's nothing wrong with the old version other than the fact that there are some trimming issues and it can't use solid edges. But the new version is in there on the website if you want to link to it. Like I say, if the profiles are there, if we get round to actually adding them all, then there's no actual reason for you to actually make your own copy of this feature. And at some point in the future, there will be a native weldment feature anyway. It's just with regards to the whole process of developing Onshape, because we only started from scratch 2 years ago, so we've still got a fair way to go. There is a recording of this webinar, so if you've missed it, or if you missed half of it, or you had to leave early, then it will be emailed to you. You'll be able to get hold of that. Question: do profiles have to be closed? The answer is yes, they do. They're closed, but they can have holes on the inside. So, in the example of the, obviously here, this has got a hole, or if you go to something a little bit more exotic, like this, then it's got multiple holes on the inside. So it does have to be an enclosed profile. It does have to be a profile that can be extruded. Okay, question about mass. Yeah, I mean that's a reasonable question, because of course when we generate this, there are no material properties on it, so you can actually box select all the parts and apply a material. And then obviously, if you start to add welds, it's going to add more mass to it. We're not quite there yet. For the moment, we are generating the part geometry with mass, and we're applying welds as symbols on drawings. Okay. Okay, somebody's trying adding profiles here, saying I created one profile and I had a problem getting to the new profile. Does it need to be added to each new part? No, again, it might just be this scenario where you're using... yes, good point. Thank you for bringing that up. What we have here is the beam which is local to this document. And if I was to actually insert this into another document, which I think I did here somewhere, recently opened this one. Okay, what you'll see here is in this document. If I go to edit this beam feature, okay, well it's not got that versions of lumber that I had in there, and the reason for that, if you're going to link to another document, you have to have a version. So in order for this to work, now you have to create a new version, okay, because you can only link with versions. So it's a good idea to do all your profile development in one document rather than have lots of versions and updating them all. So try and do as many as you can in one go. Test them in the main document to make sure that they're correct. And then once you want to use them in other documents, you then have to create a version, and then you can use those. Okay, we're way over time. Sorry about that. So what we'll do, I'll stay around for a few more minutes, but that's the end. That's the end of the webinar. We did cover a lot. Hopefully, you got something out of this. I do understand the profile generation is not a simple task. Like I say, there is a video you can watch. You can obviously rewatch this webinar as well. So I'd just like to say thank you for attending and have fun making beams. Thank you.